Hello guys, so welcome to our first lab. In that lab, we're gonna learn basically how to use Multisim, and we're gonna do something useful out of it. So we're gonna verify something easy, which is Ohm's law, the relation between the current and the voltage drop over a resistor. And we know the relation should be a linear, and the slope should be the resistor value. Okay, so we're gonna do that using Multisim. Okay, so we're gonna first, share our screen here. Yeah, this one. And as you see here, I just divide the screen into two halves. One half is the lab manual that we should follow, and the other half is Multisim itself. Okay. Also, I will just go from scratch in that lab because we don't know yet how to use virtual computer lab, how to open Multisim there. So I'm gonna go step by step on that. Okay. So let's start. So basically here, we have to experiment. We're gonna do the verification in Multisim in two ways. So the first experiment is a first way, which is intuitively changes the voltage, measures the current, draws the relation. Okay. So we're gonna first open Multisim from that link. Here is the page that will appear to you. In that page, just search for NI Multisim, which is here, this guy. Just click here. Should open, maybe, yeah. Okay, it's opened now. Now here is all the software that you can use in virtual computer lab. It's just a server that you can just log into, concurrently with other guys, and all of you guys can do whatever you want. Okay. So in here we're gonna search for Multisim. I just wrote it before, so just hit enter then. It's gonna take some time. Launch. And should be now. Here you go. Okay, it's connecting now. Okay, yes, it's opening. You don't need to double click again on this. Okay. Here is, Multisim, a blank page. Okay, and it's ready now to draw our circuit. Okay, so let's build up our circuit. So in order to list or insert components, we're gonna follow these steps here. So we're gonna go to place, this icon here, place. It's a drop-down list actually, and choose component. We're gonna add first a resistor. So here all the groups or families of components that you can add. We just click R, here I'm sorry, just click R until you reach a list called the resistor. Okay, and then just choose the default one, which is 1 kilo ohm. You just press OK, and here you go. It will go back. You might need to add other components. That's what we're gonna do now. Now we're gonna add a voltage source, right? Some batteries that we can change its voltage. So it's another list. It's called the power source. So let's write or just press P. Yeah, this is power, right? Power sources, yes. Then we use DC power because it's a battery that we're gonna change its power. And click OK. And one last thing that we must add is a ground. So each circuit should have a ground or should have a reference in Multisim. So from the same list, the list of power sources, I'm gonna choose ground. And OK. And we are done. There are no other components that we're gonna add, so we just click close here. Okay. Then we connect them to each other. It's more convenient to make the resistor, vertical. So just right click on the resistor itself again here, yes, and just rotate 90 clockwise. Here it is. Then connect them, and connect to them. You don't need to add wire. You just hover over the symbol, the terminals of the symbol until you see the mouse will change to another shape. That means it's ready now to draw connections. Then we draw one connection to the ground here and click over again and click over again and click. Good. Now we connected, our circuit, but how to measure? That's another stuff. So we need to add multimeters. So you see, guys, here is the rightmost panel here. Okay, I think the first one is multimeter, but maybe it's in your Multisim it will be different. But search for it. Just hover over each icon, it will give you the name. So we need a multimeter here. So we need two multimeters actually. One to measure the voltage. Also, that's not so important because we're gonna check here. We're gonna change its value just here from the source, and it will reflect it as you see here on the screen. Okay, but we need another multimeter to measure the current. So let's bring it here. Okay, now the current should be connected in series in our circuit to measure the current that flows in the resistor. So unfortunately, we're gonna remove this. Okay, I just did it intentionally, and we connect again the negative terminal of the ammeter to our resistor and the positive to our voltage source. You can make it more, prettier, let's say, by moving a little bit the sources to the middle. Yes. Oops. Okay. Okay, now I don't like V1 and R1. Each time you drop something, place some component, it usually Multisim give it a number. So this is the first voltage source we add. So it gave it V1. If we add another one, it will be V2, and I don't like this. So if you want to change the names, just double click on the symbol itself. Okay, go to the label, and I name it V input in the manual. Okay, if you go back here, if you go back to the manual, I call it V input. Okay, and for the value, we're gonna start by 3 volts. Okay, you're gonna start by 0. That's up to you. That's fine. For the resistor, again, double click. We're gonna leave the value as 1 kilo ohms, and they're gonna change the resistor name to R, not R1. I don't like. You can leave it. That's up to you. That's fine. One last thing is we're gonna connect the voltmeter here. The voltmeter the multimeter, which will work as a voltmeter. Okay, in parallel with the voltage source. So negative goes with the negative, which is the ground, and positive goes with the positive. Okay, and just to do it in 2 steps, just to make it pretty. Okay, good. Oops. You can just fix it like this. It's not a big deal. Okay. This is a multimeter. Both of those are multimeters, so they can measure current, voltage, and ohm. I mean, measure the resistor value itself. So we're gonna choose for that. We're gonna choose a meter, and leave it on a side here. Okay, and for that it's voltage, so we're gonna leave it, but leave it on a side also. So whenever we change, we see the reflected value. Okay. Now our circuit is ready. Again, we can make it prettier. Good. And good. Okay. Now we are ready to run the simulation to change the voltage, which is the input Vn, and see the current each time. Okay. So to run the simulation, we choose simulate here, this icon. It's a drop-down list again. So we just click this green arrow. We can also do that. It's a shortcut here. You can do both. Okay, so now it's running. And since it's running, the multimeter started to measure. So this guy here, which is acting as a voltmeter, is measuring 3 volt, which is the voltage of the battery. And this guy, which acts as a meter, is measuring 3 milliamperes. And we know, of course, because we have just 2 components. So the voltage on the resistor is 3 volts, so 3 divided by 1 kilo, it will be 3 milliampere, or 3.003 amperes, which is 3 milli. Okay, now it's time to, change the value and see the reflecting current. Okay, but before that, we should, record here the reading that we measure 3 milliamperes. Okay, and then we go to 6. We should follow this table here. Okay, you can't unfortunately, change a value of in the circuit while there is a simulation running. Okay, so we must stop first the running simulation, and again double click on the symbol, in the value, choose 6. Okay, then run again, log 6 milliampere and 6 volt, and you can just continue, in that sequence. Okay, so that was for the first experiment. So after that, we're gonna fill this table. Okay, and let's do it. So we have here 6 milliamperes. Then when we change it to 9, it will be 9 milli. You're gonna do it, but it will be like this, and 12, then 15. It's a very easy experiment. The main purpose is to learn multisim, not to verify Ohm's law. Okay. Then we're gonna open Excel sheet. So let's open one together now. Okay, new. So in that Excel sheet, we're gonna take these values, and put them somewhere here, just to change this. And we're gonna draw them together. So we're gonna go to insert and choose this guy. This, yes, that's what we have. So we just copy, and here we paste. Oops. So you're gonna paste it here, in this text box, and the text box is smaller than the figure, so you can just resize it appropriately, in a proper way, so to include your drawing. But I will leave it to you. So you just copy this graph. You can copy it, for example, as maybe it doesn't copy because it's not a plot or an image. So you can convert it to image and paste it here. Okay. So that's for the first experiment. Okay. Let's say we have, here we have only 6 values for the input: 3, 6, 9, 12, 15. But how about if you have, a device like a diode, and the relation is a little bit complicated. It's not linear like this. In linear relations, we need just 2 points, but we make 5 here. Although 2 are useful, are enough, I can say. But for nonlinear devices like diodes, no, you must have many points to test, change the voltage, and test the current each time for many values. And such a way it will be tedious for you, and of course error prone, because once you repeat the same step each time, for many times, that will increase the probability of having a problem in measuring, or some errors in your measurement, some mistake, So there is another way to do that, which is what's called the sweep parameter, or the parameter sweep. So the second experiment here is called measuring, Ohm's law using parameter sweep. Okay, which is very powerful feature in Multisim. Okay, so let's have it together. So basically, we're gonna stop this. First we're gonna create a new project for it. So you just click on this white blank and choose blank, create. Since it's the same circuit, okay, so you just need to copy. So Control A or Command A in Mac, then Control C or Command. I think it doesn't work. Maybe it's right-click copy. That might be better. Then go to design 2 and paste. And it choose, good location and put it. Now we don't need actually the multimeters, we don't need them. I can just, remove. I will just keep them, but in the manual I kept them, but you can just remove, because we have our way now to do the measurement, which is automatically the Multisim will do the measurement for us. Okay, so let's do it. First, I like also to to change the names back to V input and R input and R, not R1. I like that better. Okay, and here is let's now do the simulation. We will not do it one by one. We will not change this, value by value. And by the way, you can leave it with whatever value here. Multisim with parameter, so we will just ignore the current value for the input. So to do this parameter sweep stuff, you press simulate or click simulate. You choose analysis and simulation, and choose DC sweep here. And for the DC sweep, you should first choose the parameters that you're gonna sweep, that you're gonna change its value automatically, which in our case here, V input. If we put this V input here, so we're gonna change this, 0, 3, 6, 9, 15, whatever, and it check the current each time. So first we choose the source of the sweeping, which is V input. Okay, and we're gonna now choose the starting value, the end value, here's the stop value, and the increment. Let's do it, for example, same range, 0 to 15, but we're gonna do it now with a very fine step, which is just half a volt. That will give us 30 points. 30 points. Okay, and you can do 3, and it will just give you 0, 3, 6, just like the first experiment. You can do whatever, but if we do it with half volt, this will give us 30 points in just one click. And if we do the same in the first experiment, we should do 30 steps to accomplish that. Okay, now we choose the parameters that we should sweep. Then we should choose the value or the parameters that we're gonna measure against. When we sweep that V input, what we're gonna measure, And in our case, we're gonna measure the current in the resistor, IR. So we just make add here. Okay, then we click run. Automatically, Multisim will draw for us the linear relation, or the he will change Multisim will change V input to 0 to until it reaches 15, and in each case he gonna measure the resulting I, and you're gonna store this somewhere in the system with software and draw it for us. But we as an engineer, we like Excel much better. So we're gonna export this to Excel, and for this you guys can see there is an icon called export to Excel. Here is again, just hover over it, should show the name, export to Excel. You just click here. Then maybe you have many sources of sweeping, like V input 1, V input 2, but we have just one here. So we just check the source of the sweeps that we wanna export to Excel. You might check them all, then you can just click here. If you wanna choose only some of them, you just check and uncheck, check and uncheck. Okay, so if you wanna this one, do we want it? So we're gonna check it like this. Then we press OK. OK again, and just say that it will be exported to Excel. And it's gonna take a few minutes. Then we wait, and the magic happens now. And now we have 30 values, not just 5 like the first experiment. Here is the X trace. X means the parameters that we swept, which is the input. Okay, this is the independent. If in mathematics, this is the independent, variable, and Y is the vertical parameter, which is a dependent variable, which is I now. Okay, then we wanna plot them together, you just highlight, those, then you press Shift, Control, and the arrow down. It will give you all the two columns. Okay, then insert this icon here and this guy. You have it here. You have here the relation between I and V from 0 to 15. This is 15. Okay, guys, then you take this, copy or whatever, you change it, this is up to you. And again, paste it in here. Paste it in here. And take these values and put it in the table here. Okay, that's your first report that you're gonna submit to me. Okay, this is our first lab report, and the lab reports have 30% of the grade, 30 degrees out of 100. Okay, so guys, I hope that was clear for you. Okay, I'm sure if you watch this video, you should do it yourself in maybe 15 minutes. It's really easy. Okay, also we're gonna meet again, in our first lab on Wednesday, and I'm gonna walk you through again the steps if you have any difficulties. Okay, thank you very much, and see you. Bye.